Hello again and welcome to another video. This time we're going to do question 12 on Pure Core 2 2020. Okay, this one looks like parametric integration. Yeah, I've got a bit of a history with recommending that parametric integration won't come up, and it does, so make sure you know this. Okay, so x is 6 sine t, y is 5 sine 2t. We've got to show that region R is given by this. Now, the formula for parametric integration is y dx by d theta, or if your parameter is t, like in this case, it's going to be y dx by dt. That's your parameter, and you'll be between, like, whatever x is here, that's going to be like your t value, but at x1. So how can I denote that? I could put t at x1 like that, and this is going to be t at whatever x2 is, yeah? So we need to find t's here and here, yeah? Now, that's pretty easy because that's where y is 0. So y 0 equals 5 sine 2t, and that means that sine 2t equals 0, and that means that 2t equals 0, or pi, and that means that t is 0 or pi over 2. Now, at pi over 2, you've got you want to know which one's which. So if we plug in 0 into here, we get x equals 0. So t equals 0 corresponds to that one, and t equals pi over 2. You do want to be slightly careful because sometimes the limits can switch and that can really confuse people, but here it looks like it's going to be the way around you probably guess, because t equals pi over 2 gives x equals 6 here. So we do know that that's 6 now. That's kind of handy. Okay, so we're going to just use this formula. The t values are pi over 2 and 0. And we're going to have now y, which is 5 sine 2t, and we're going to be multiplying that by dx by dt, which is 3 cos 2t dt. But of course, we can actually write this. We've got two double angles here. Like we can write this. Oh, and I've written 2t there. That should be just. Let me just check that. I've done that so badly. I am so sorry. Wow, what just happened there? 6 cos t here. That's better. Now we can just use the double angle on sine here. We're going to get 10 sine t cos t multiplied by that cos t. So we're going to get 6 cos squared t. And so it works out all very nice at the end. Apologies for that. That was a very bad bit of differentiation there. So we get 60 sine t cos squared t dt between pi over 2 and 0. Okay, that gets us at 3 marks. Show by algebraic integration that the area is 20, so we're going to integrate this. Now this is really nice because it's kind of that form, f dash of x, f of x to the power of n, and integrating anything of that form always integrates to f of x to the n plus 1 over n plus 1. You can use substitution though if you don't notice this, yeah? If you would say let u equal cos t here, things are going to go very nicely for you, because if you let u equal cos t, and this is just another way of doing it, then you're going to get du by dt is minus sine t. So I can trade minus du with sine t dt. Now the reason why I've organised it like that is I've got sine t dt in here, and so it's going to become sine t dt disappears and becomes a minus du, so we'll put that there, and then cos squared t becomes u squared du. Between, change the limits for u, cos of pi over 2 is 0, cos of 0 is 1, and so that's actually going to go to minus 60 between 0 and 1. Oh, I can integrate it now. That obviously integrates to u cubed over 3, which is what I was saying before. You could just directly integrate this to minus cos cubed t over 3 with a 60 outside as well. That's perfectly valid between 0 and 1. When you plug in the 0, you get 0, and you plug in the 1, you get minus a third, and so you get minus 60 times minus a third, which is 20. Okay, last part. Part of the curve is you smooth more profile of a small dam. Okay, yada yada yada, it's in meters. The vertical dam, that's 4.2, that's obvious. Now they want the width of mn of the walkway. That's what they're asking for, the width of the walkway. So that's this width here, yeah? Now that occurs where y is 4.2. So I'm going to have to use my parametric equations and set y equal to 4.2. and I'm going to have to find the corresponding values for t, and that's going to give me 2t equals essentially a number very close to 1. I haven't actually got my calculator with me. That's going to make things difficult. Can I find one? 1 second. Yeah. Okay, let's go straight to t. Once you've done your inverse sine, basically, and this, I might have to begin with 2t first. Let me just get the Desmos calculator out. Okay, 1 second. I need to do inverse sine of 4.2 over 5. Inverse sine of 4.2 over 5. Okay, but I need to be in radians, that's annoying. 1.19, and then I'm going to be basically, oh, I've typed it in wrong. I'm useless on a calculator, don't trust me on a calculator. 0.99728. Okay, so 2t equals 0.99728, or do 2 pi, just pi minus that answer, because that's the rule of thumb for sine. So pi minus, let me just do that 1 second. Okay, that gets to 2.144. I'll just write it down like this, and then you're just going to halve those two values, and you've got t. That's a 99728. And you've got t, and that comes to 0.4986 or 1.072. Now all you're going to do with those t values is find the corresponding x values there and there by using x equals, what was it, 6 cos t, 6 sine t. Plug those values in, and you're going to get two x values, which are 2.869 and 5.269. Subtract, you're going to get the width is 2.4 meters. Done. And that's it. Okay, hope you enjoyed the video and it was useful. Bye.